Hi, I apologize for not being able to present in person, but thank you for the award and for letting me talk about a topic that's been a big interest of mine in the last few years, which is also the title of this talk, Sublayer Modularity in the Grammar of Graphics. So I'm aware that a lot of us here have certainly heard of the grammar of graphics before, if not experts already. But just to reintroduce it very briefly, the grammar of graphics is an abstraction that unifies various chart types. So traditionally, you would have a taxonomy of chart types, including the bar chart, the stack bar chart, the pie chart, and so on. And in graphing libraries, each type would have their own corresponding function. But in the grammar graphics, you can express these charts as underlyingly a plot with a single bar layer that can sometimes stack in their position and be rendered in polar coordinates. So instead of having a huge list of monolithic chart types, we get a single grammar that unifies them at a high level. So the grammar graphics is a big framework that revolves around these components that are listed in full here, and there's a lot to like about it. But the most powerful feature of the grammar is the fact that elements, or also called layers, are modular. So you can have multiple layers in a plot, and layers are independent of one another, so it's easy to collect them up or swap them in and out. To demonstrate the power of this design, take, for example, this relatively modern chart type called the rain cloud plot. It looks complex, but it's really just a mashup of a density contour, boxes and whiskers, and dots. And so in R's ggplot2, for example, you can express that simply as a single plot with three layers, geom density, geom box plot, and geom point, that all share the same X and Y aesthetics. And because layers are the most tangible and flexible part of the grammar in this way, many implementations of the grammar graphics privilege the layer component, and they break it down even further. So whereas Wilkinson's original grammar just had element, ggplot2 and other popular libraries like JavaScript's Vega Lite and Python's Seaborn break the layer down into its subcomponents using ggplot's terminology that's stat, geom, and position, although in this talk, I'm going to ignore position for a bit. So this design is what I call sublayer modularity. And in practice, it's often implemented in a very specific way where the sublayer components are largely invisible to users. You know this if you've used ggplot or any one of these other libraries before, but to plot something like a histogram, this is all it takes to express that in the code. You have a layer level abstraction like geom underscore histogram, which saves you from having to think about the fact that the layer bins the data with stat bin and calculates the location of each rectangle's four corners with geom bar. Instead, that level of internal detail is largely reserved for developers. And for reasons I won't go into detail here, sublayer modularity essentially makes developers' lives easier. And it's responsible for spurring this rich ecosystem of extension packages, as some of you might know. So sublayer modularity gives you the best of both worlds. On the one hand, it addresses a lot of practical constraints for the growth and maintenance of graphing libraries. And on the other hand, as we just saw, users of the grammar can still get away with thinking about layers like geom underscore histogram as the fundamental building blocks of visualization and not have to worry too much about the lower level details like the stats and the geoms involved in the layer. And this design has clearly served users well, given the massive popularity of these libraries. So far, I've shown how the grammar of graphics can make hard things easy, but now I want to transition to talk about cases where some easy things are hard to express in the grammar, which is the focus of this talk. So for example, here we have a plot where our first layer is a box plot. And let's say a user wants to add a second layer that annotates just the value of the upper whiskers. And obviously, this annotation layer is not a novel chart type, and so we should be able to recycle some existing things in our toolbox. And given what we've just seen about the design of sublayer modularity, a naive approach would be to just swap out the sublayer components. So in the case of the annotation layer, it should recycle the box plot stat that the first layer uses, but use a label geom instead to draw the box plot variables as text. Unfortunately, this actually doesn't work in practice because the box plot stat isn't compatible with the label geom. It turns out that it's only compatible with the box plot geom, whatever that means. So geom box plot with stat box plot makes a good layer, but geom label with stat box plot makes a bad layer. And from the user's point of view, this is a bit of a black box. The way to make this annotation layer work would be to go through the developer's interface to sublayer modularity. And please don't read this code. It's only here to exaggerate the scariness of the approach. But basically, we created a modified copy of stat box plot such that it can now be paired with the label geom to annotate the value of the upper whiskers. So once this new stat box plot ymax object is defined, users can then exploit it in their code to get the desired plot like this. But we already see clear problems with this approach. First of all, users aren't developers, so they can't write that big chunk of code themselves. Second of all, this isn't what users sign up for when they choose to learn the grammar graphics. The code we just saw isn't part of the grammar. That's just implementation level details. And most importantly, it feels like we're replicating the problems of chart taxonomies at the layer level because we're making an entirely different stat just to slightly modify the behavior of an existing layer. So this seemingly trivial annotation problem turned out to be quite difficult. And to be fair, this really is a hard problem to solve because you don't want the grammar to get too complicated for the users. But at least where sublayer modularity is concerned, it would be really empowering if users were able to come up with novel combinations of stats and geoms in a layer to really exploit the full expressive capacity of the grammar. So what I want to do in this talk is to build up a more powerful mental model of sublayer modularity. And I'll start with some good news. Very recently, as of about 2 or 3 years ago, ggplot actually solved the technical challenge of implementing this. I'm pretty sure they're the first to do it, and they do this very elegantly, which is why I'll use it as a case study here. So the modern ggplot2 now provides a set of what they call delayed aesthetic evaluation functions, which essentially makes the user's interface to sublayer modularity more expressive. So the box plot annotation layer can now be written like this, where we now do recycle the box plot stat and combine it with the existing label geom. But we also do a little extra work to make sure that the two fit together in a layer, because remember that they don't out of the box. So now we're starting to get something like a proper grammar at the sublayer level. And roughly speaking, this new piece of code here says, when the layer is being built, make sure that the stat receives yvar first. Then, after the stat transforms the data, use the computed variable ymax to remap to the y and label aesthetics for the geom. If this sounds confusing, actually it should be, because like I said, this only solves the technical problem. The bigger problem is that users aren't prepared to express what a layer should do in these procedural terms. Like, this requires users to make references to different steps in the internals, but ironically, they don't get to see what happens there because the grammar abstracts away from those details. So to summarize, this is a mental model problem as much as it is a technical problem. And so we need a model that strikes a balance between too much detail and too much abstraction. So here is my proposal. I think that a better mental model of sublayer modularity is one that emphasizes sublayer processes. So instead of thinking of a layer as simply composed of a stat and a geom, I think it's more useful to think of a layer as almost like a pipeline that takes the user's data and prepares it to be drawn according to the layer's specifications. So of course, a lot of stuff must happen here, but I focused on just 4 snapshots of the layer's data in the pipeline. They're what I call before stat, after stat, before geom, and after scale. And these are significant because they're roughly the inputs and outputs of stats and geoms. So in this new model, stats and geoms are more than just properties of a layer. They're tied to processes that we can observe. And the really powerful thing about motivating these 4 specific stages is that ggplot internally represents them as data frames. This is nice because users are familiar with data frames. They think in terms of tabular data, and it's the same data structure that they feed as input to the plot. So exploiting that connection, I've developed an R package called ggtrace as a complement to this mental model. And among other things, it lets us take a snapshot of the layer's data at each sublayer stage and inspect what's going on. So ultimately, what you get from a combination of this mental model and the package is an understanding of sublayer processes as not just any pipeline, but specifically a data wrangling pipeline. So this gives users an intermediate level abstraction that's accessible and also immediately practical. So now I'm going to transition and spend the rest of the talk returning to our box plot annotation problem as a mini pedagogical exercise. So I'll first show how the box plot layer itself works in procedural terms, and then I'll show how we can derive the annotation layer from it. So to start, the user data for our box plot looks like this. It's a tidy data with a discrete xvar variable and a continuous yvar variable. These columns are mapped to the x and y aesthetics in our plot. So our plot has one box plot layer that draws a box plot for each categories of x, showing the distribution of y values. And now we're going to intercept the data underlying this box plot layer at the sublayer stages we care about. So we'll watch as the layer data becomes more and more drawing ready. And for the sake of time, I'm actually going to skip the after scale stage, but it follows a similar logic, and I talk more about it in my paper. So in the layer pipeline, the first sublayer stage we care about is the before stat stage. And this is the point in the internals where the initial aesthetic mappings are applied. So we now have columns in the layer data named after the actual aesthetics like X and Y. And these other columns just track which observations belong together in a box plot. But crucially, this before stat stage is significant because it validates the layer's choice of stat. In the case of the box plot stat in our layer, it needs information about both X and the Y, and that's satisfied here because the layer data at this point has the X and Y columns. So this is directly observable and very easy to reason about for users. And as long as the stat is satisfied, then it transforms the data and spits it back out for us to see in the after stat stage. Here, the data has been collapsed into 2 rows, where each row in the data now represents a box plot, and we have new columns for the box plot statistics, like the quartiles and outliers. This is also the point in the sublayer pipeline where users can declare more aesthetic mappings using the new set of ggplot functions that I briefly showed before. But we didn't use any of them here, though. So if we just proceed and intercept the data next in the before geom stage, we find that the data is unchanged. The significance of the before geom data is that it validates the layer's choice of geom, which is geom box plot. Here, geom box plot requires the X column to position the box plot, the lower and upper columns for the boxes, the Ymin and Ymax columns for the whiskers, and so on. And unsurprisingly, the box plot stat and the box plot geom in our layer are designed to work together. So the geom has all it needs from the stat. Since the sublayer components fit together and have what they need, the layer data continues moving through the pipeline until the final drawing-ready data for the layer looks like this. So the same kind of data, one row for each bar, but just augmented with more columns. Of course, now the layer actually needs to be drawn, but users don't have to care about that detail. Because it turns out that just being able to understand the data pipeline is sufficient for users to make the most out of sublayer modularity. And I'm going to demonstrate that now, returning to the more difficult box plot annotation layer. So for our box plot annotation layer, let's just repeat the naive approach and swap out the box plot geom with the label geom and start from there. Again, the plot errors with the same message we saw before, and it specifically blames the second layer. And here, we want to focus on this last part where it says geom label requires some missing aesthetics. It's a bit puzzling though. For example, it says we're missing a Y aesthetic, but we specified it in the code on the first line. But our mental model can now help us understand the issue. The geom is complaining about missing aesthetics, so something must be wrong with the data that it receives. So if we go look at the before geom snapshot of the second layer, we do indeed see that the Y column is no longer present, and there's no column for label. To satisfy our label geom, both those columns must be present by the time the data reaches the before geom stage. What's crucial here is that as long as we can diagnose the problem in this way, in terms of sublayer processes, the solution translates directly to the code. And this is where the new set of functions from ggplot comes in. We can think of them as interfacing with our mental model like this. So we can use them to intervene in the pipeline and modify the layer data as it goes through the pipeline. And here's how that works. We first express what we want from the layer given what we just found. So make sure that the label column exists by the time the geom receives the data, and also make sure that the Y column is available to satisfy both the stat at the start and then the geom later on. And crucially, use the Ymax variable representing the upper whiskers that's computed by the stat and available in the after stat stage. This kind of declarative statement that we construct by consulting our mental model can then be expressed in the grammar like this, which is the same piece of code that we saw earlier. So we simply plug that into our annotation layer, and this gives us the plot that we want. And now if we look at the before geom snapshot of the layer data again, then we do see that both Y and label are present to satisfy the label geom and make it compatible with the box plot stat. And that's pretty much all there is to it. I think that this is very empowering for users and lets them really build an intuition for sublayer processes through practice and trial and error. So to sum up, we've seen how users are still quite limited in exploiting sublayer modularity. Namely, it's very difficult to come up with novel combinations of even familiar stats and geoms. But I've shown how a mental model of sublayer processes as a data wrangling pipeline can help, especially if you use a tool like ggplot that also lets you express that in the code. And I hope I was able to convince you that this intermediate level abstraction still manages to be pretty accessible, partly by leveraging users' existing experience in data analysis. Thank you.